containing more than carbon atoms. So the compound that contain more than carbon atom is the heterocyclic compound. So there we have those that contain oxygen, those that contain nitrogen, and those that contain sulfur. It may be one heteroatom or it may be two heteroatoms. So when we're talking about heterocyclic compound can be classified into three. So here we go. We have the number one. We have those that are five-membered. We have five-membered heterocyclic compound. We have those that are six-membered heterocyclic compound, and we have those that are known as condensed heterocyclic compound. Now, with respect to that, let us discuss more about this. When we're talking about heterocyclic, I said the heterocyclic compounds containing at least one atom than carbon as a ring members. So that means from heterocyclic, then we must have what we call the ring members must be present here. Now, how do we get the heterocyclic compound? Take note, they are more stable, okay, and more aromatic in nature. For example, now, if you look at this structure that we have here, this is the structure of benzene. Now, this structure of benzene, if you then come to this place and replace this particular region here, so if you replace it with nitrogen, or you replace it with oxygen or sulfur, or you replace it with NH, or you have NH here, you have N here, you have N in this place, it has become what we call the heterocyclic compound. But take note, since you are using this structure that you have here, this one is a six-membered heterocyclic compound. Take note of that, six-membered heterocyclic compound. Okay, now let's talk about this. We're going to start with what we call the five-membered heterocyclic compound. What do you mean by five-membered heterocyclic compound? They are the one that contain five. Look at it. This is 1, 2, 3, 4. Then we have something here like this. Then we have something here. So anyway, you see something like this, it represents what we call the five-membered heterocyclic compound. So five-membered heterocyclic compound, they are considered as being from benzene. Okay, they originated from benzene by replacing the C to C that we have there, by replacing it by what we call a heteroatom. That means we replace this one that we have here, we replace it with one, which is called a heteroatom, such as this one that you have here now. Okay, then you have something here like this, or you have another structure that looks like this one here. Okay, in this place you can have O here, you have something like this. Take note of that, still five-membered. Or you have another structure that looks like this one now. If you have a structure that looks like this, remember, this is N, this is H here. Anyway, you see this type of structure, take note, it is still a five-member. 1, 2, 3, 4, 5. Remember that. Now, this structure that we have in this place, we have more than this, but to mention a few of them, this one that we mentioned here, they are five-membered heterocyclic compound. Okay, now let us dive in further. Regards this one that I have mentioned in this place, what is the name of this one that we have here? Okay, let us look at their name one after the other. The first one that we have in this place is known as thiol. Take note of that. Another name for this thiol, we can also call it the thiophene. Okay, because of the S originated from thiol that we have there. The O that we have in this place, that represents what we call the furan. Another name for this furan that you can also just use for it, we have what we call the ozole. Take note of that. Now, the name for this one that we have here, we call it pyrrole. And another name for this one that we have here now, you can also call it the azure. Now, this one that I have mentioned in this place, they are typical example of five-membered heterocyclic. Now, let's discuss about the next member that we have here, six-membered heterocyclic. Now, let's talk about the six-membered. When it comes to six-membered, we can make use of the structure of benzene to identify them as well. So you just have to keep on adding the heteroatom together with this compound. So the six-membered heterocyclic, they are formed from when the heterocyclic compound with six carbon atom, in which one of them is replaced with what we call the heteroatom. Okay, now here we go. From here now, you can draw the structure of benzene. When you draw the structure of benzene like this, you bring this one down to this place. Now, instead of you closing this one here, you are not going to close it, okay? Now, for example, now, if you put N in this place, then you then balance this one here with this, like this, that we have here. This one here represents what we call the six-membered, okay? Now, another structure we can also have there is when you have something like this one here, then you put O here, then you have something like this. Now, you can put this one here, take note. Then another one that we have there, that also represents six-membered is, you can have a structure like this one, then you put S in this place. Now you put the same thing here as well to balance it up. Okay, remember it is unsaturated. Now this structure that you have on the board, they also have their own name as well, just like the five-member that I just explained. Now the name of this one here, we call it azine. Take note of that. That is the name. Now being azine, another name for it is what we call the pyridine. Take note of that. Pyridine. Okay. Then the next one that we have in this place, we call this one the pyran. And another name for this pyran is known as the 4H. Okay, because of the junction at which the double bond is being attached to it, we have what we call the 4HOZ. Okay. Then the last one that we have here, we have what we call the thiopyran. And another name for this one, we call this one the 4H, followed by where we have what we call thiane. Okay, that is another name for this one that I mentioned here. Now you see that the first set of the heterocyclic compound that I mentioned in this place, we have the first set which are five-membered. Take note of that. But one heteroatom. Now we have another one called the 6-membered, which is what? Which is one heteroatom. Take note of that. Now let's talk about what we call the 5-membered 2 heteroatom, or more than 2. Then 6-membered 2 heteroatom as well. Now, when it comes to 5-membered heterocyclic, those that are they have a more than one heteroatom. Take note, more than one heteroatom. Now we can start with this one that we have here. Now, where we have this particular compound here. When you have N here, you have H here, then you have this one here. Now, this particular one that you have here, replace it with what we call hydrogen. The moment you replace it with hydrogen, it has become what's called the 5-membered heterocyclic with what? With 2 atoms here. Now, you put this one here as well. So, what is the name of this one? We call this one the pyrazole. That is the name of this one here. So another name for it is, if you can't, by what you have a 1,2, it represents what we call 1,2-diazole. That is the name of this one here. The next one that we have there, we have this. Then here we have this particular one here. Then in this place we have this. Come to this place that we have here. Remove it and put N there. Okay. Then after doing that, you can come here and put this. Come here and put this one here. Now this structure that we have on the board. Remember this 1, 2. So this will be 1, position number 2, position number 3. So 1 and 3. Okay. Position number 1, position number 3. Okay. So what is the name of this one? The name of this one here is called